Awesome. Thank you so much. Whatever you said, I think I need some Google Translate live translation, even though that doesn't work well in most cases. So, hi, I'm Björn. I work for VMware. So I'm here to talk to you about a very long title, which probably is, I hope I can meet all the buzzwords in there. Quick disclaimer up front before I start anything. So there will be a few items that are still in development inside VMware, but I wanted to get you like a sneak peek of what's happening in the near-term, mid-term future. So standard disclaimer, that's it. So who am I? So I live in Germany. I'm working for VMware now in the, I think the 10th year now. So I've seen a lot of virtualization projects moving into private cloud projects. So I'm part of a team called Application Platform Architecture right now. So I help customers that run traditional infrastructure to embrace these new modern application frameworks to actually deliver value into their business. Because typically, if you start only with simple virtual machines, you don't really add a lot of productivity in the development workflow, right? So how do we make DevOps processes work in a virtualized environment on-prem, but also in the cloud, right? So why is it happening? And I mean, this is something, just a very generic, wow, like this? Okay. So in general, the overall topic of agility means that you're differentiating as a business a lot faster, right? So if you look at traditional companies, how long it took them to reach a certain valuation as a company, and how long a modern company that is applying modern and agile methodologies to actually building their business, how fast they reach a certain level of valuation, right? So it's all about how do you create value faster, and this is all done through agility. So can you maybe tune it down a little? Better, okay. Okay, so how does it all happen, right? So we have a very basic relation between the business, the application development, and the infrastructure, right? So on the more left-hand side, we talk about digital transformation, and on the right-hand side, we talk more about this kind of notion of DevOps, right? But in the end, it turns all around the application, right? So how do I ship new features, new functionality, react to user complaints or wishes, or to market needs a lot faster, right? So how do I go through the cycle a lot faster than ever before? So the app is in the center, right? But we're seeing the applications changing dramatically, right? So in a monolithic development cycle, you have a long time, right? So you do releases once a year or once every 6 months. But this is now changing a lot to actually becoming microservices architecture in addition to what the legacy applications have been doing in the past, right? So there's a lot of movement over there, even though the legacy side isn't dying immediately, right? So, and there will be, I believe, there will be a hybrid world for quite some time where legacy applications sit next to cloud-native applications all the time, right? So, and I come to that challenge in a minute. But for the microservices level, and this is research that has been published recently, it's a Devops report, and I think many of you have seen probably a slide like this in a different talk already. So the elite performers in the DevOps movement, they are deploying really in really high frequency, right? They can basically deploy on demand, right? And they don't really care how much that means. Their recovery time is less than an hour, right? So their lead time for changes is less than a day. So these are all metrics that traditional companies need to think about how are they actually performing, right? So if a realization of value takes a year, that is a year of lost value if you look into the development cycle, right? So new features are shipping into the software, but the software is not put in production that fast, which is not good. And if you just take one of the examples here, so the elite performers versus the low performers perform like 106 times faster than the low performers, right? I mean, this is a big difference. If you think about it, if you're like 106 times slower, then how long can you actually maintain that business? So that's a challenge that everybody has to deal with, right? So long story short, DevOps helps companies to move faster, right? I think we all agree with that. The question is, how do we unlock the potential of DevOps, right? So, and I'm not saying this is a pure technology play, but how do we unlock this? And thinking about taking a step back. So in the past, there are many standardization bodies and areas of open governance, right, where people come together to agree on a standard, and that standard is then implemented as a new technology standard, for example, for interoperability and for moving faster, right? So if we weren't agreeing on, let's say, standard codecs for telephony, for example, you couldn't pick up the phone and reach me in Germany. Otherwise, it would be, I don't know, at the end of the border, for example, it wouldn't be able to transmit that signal any further. And there is one governance body that I admire a lot that has been introduced over the past couple of years, which is the Cloud Native Computing Foundation. So I would even argue that they are becoming similar to the standardization bodies above. They are becoming a standardization body for cloud native technology, and actually becoming an open governance body where not one company can do whatever they like to implement something, but it has to be a joint agreement to do something. And one of the technologies that comes out of the Cloud Native Computing Foundation is Kubernetes, right? And Kubernetes' role in the DevOps movement, I mean, DevOps is not about a technology, it's not about implementing a software and it's DevOps, right? So that's for sure. But I would argue that Kubernetes is actually the first multi-cloud API for DevOps processes, right, to interact with. Because it standardizes in a way that you can get Kubernetes from any infrastructure nowadays, from public cloud, from private cloud. It works consistently across all the infrastructures, right? And we heard earlier there were mentions of edge computing, same thing, right? So it doesn't really matter. Public cloud, private cloud, edge computing, you probably get the Kubernetes API from everywhere. So, and this is a super important thing, but Kubernetes isn't just that, right? So Kubernetes is even more. So when we clicker died, okay. So Kubernetes is even more. So Kubernetes is actually a platform, right? So this is a slide that my colleague Joe Bida is using to explain the role of Kubernetes. So right now, this is all about container orchestration, right? But in essence, this actually goes way beyond. So Kubernetes is a platform where you can build platforms on top, right? So the implementation of how do you make Kubernetes work is something that is hopefully going to be less and less important in the future, right? So one of the big themes in the community is making Kubernetes boring. So it's not exciting to run Kubernetes, it's exciting to build on top of Kubernetes, right? So the inner workings of Kubernetes just need to be there and work, right? And this is what the open source community is focused on. So what's VMware's role in that? So VMware is a big fan of open source communities. We're actually a founding member of this Cloud Native Computing Foundation, but also Cloud Foundry Foundation. We're heavily engaged in projects like OpenStack, but also in blockchain technologies, because we want to help our customers to actually unlock these potentials that the open source development brings, right? So having standard implementation interfaces will help all customers to avoid lock-in into a platform, right? It doesn't matter if it's a public cloud, private cloud. As soon as you start building on open interfaces, you'll be able to move your workloads where they actually bring or realize most value to you, right? So one of the projects that we started internally that has moved into the Cloud Native Computing Foundation over a year ago now is a project called Harbor. So who knows Harbor? One. Okay. So Harbor is a container registry. So it started out as an internal project quite some time ago inside the VMware China office. It's a Docker registry, but enhanced by tons of features, right? It has integration for Helm charts now. It lets you integrate with your Active Directory LDAP infrastructure. You can replicate images to and from other harbors or to and from other container registries like Docker Hub or, I don't know, a public cloud container registry, for example. It has very powerful logs and audit information, but also we use Claire, for example, to scan images for known vulnerabilities and just show it, right? So this is just a view of one of the images in there. So you can see it's actually mostly green, but you see the CVEs listed in the list under there. So highly successful. It's part of the CNCF, so it's no longer a VMware product. It's a project. We embed it into our portfolio, right? So when you buy Kubernetes from us, you get Harbor as a supported option, but you can run Harbor anywhere you like. So another project that we've been focusing on for a long time already is Open vSwitch. So you probably heard of Open vSwitch if you ever looked into Linux kernel or any kind of open source system. So Open vSwitch is the foundation for many of the modern network enhancements in Linux kernel-like environments. And there are tons of other projects, right? So you heard of Clarity probably. So any front-end designer? No. Clarity is a design system that embeds a lot of best practices and guidelines, which is used by tons of people. It's how we build our user interfaces, but it's also leveraged in a larger context. And there are other projects. So Concord is our open source project around blockchain. Lightwave is around identity management, Turn. So you can find all of these on our GitHub sites, and there is a good overview of what's happening there. So if that's of interest, I strongly recommend just hopping over and taking a look. But one thing that really stands out these days is our commitment to Kubernetes, right? So Kubernetes, in my opinion, is an infrastructure abstraction that allows you to talk to infrastructure in a new way. And this is something that VMware has been keen about for a long time already. So, and if you look into the Kubernetes community contributions over the past year, so this is from the CNCF, so actually the number 2 committer to Kubernetes these days is VMware, right? Might be surprising, and I'm not saying this is not a quality thing, right? So this is not the most high impact changes or whatever, right? But this is like, just to give you an idea of how much we're committed to the project. Of course, this wouldn't work if the others weren't there, right? So this is all about a community effort, but we put a lot of effort into this, making Kubernetes successful, because we believe in the same idea that Kubernetes brings, being a multi-cloud API abstraction. That's something we have been looking for a long time. So some of the projects that you see here come from a company that we acquired last year named Heptio. Heptio was founded by 2 of the 3 founders of the Kubernetes project, Joe Bida and Craig McLuckie. So they founded a company called Heptio, focused completely on open source Kubernetes, and they came out with a ton of projects like Contour, for example. It's an ingress controller for Kubernetes. Another tool is Velero, that was formerly known as Arc, to do backup and restore of Kubernetes clusters and the workloads in them, to move them from one infrastructure to the other. Gimbal is a global ingress load balancing platform that has been developed jointly with Yahoo. Sonoboy is used as a conformance check tool inside the Kubernetes community itself, right? So these are all tools that we have in the portfolio that we support in the community. At the same time, they are part of the software that we deliver to our customers. So another tool, and you'll see a quick demo of it right there, is Octant, that was just launched a couple of weeks ago. Octant is basically a UI for your Kubernetes API, so you can connect it from your local machine and actually see all the objects that are happening inside the Kubernetes cluster and actually interact with them. So you see what's going on, you see the objects there. So it's quite an interesting tool if you interact with the Kubernetes API server to a certain degree. It also helps you to see what kind of access rights you actually have, right? Because you only see what you have access to. So that's pretty exciting. And if you're interested in more of the Kubernetes and open source developments, there's one thing that we continue to do that Heptio started back in the day. It's called TGI Kates. Thank God it's Kubernetes. That's the translation to it. And so there's every Friday there is a live session hosted where somebody will sit there, play with an open source project, try to get it working, and share the learnings as part of that live video, right? So it's a open community forum, so to speak. So you come together in a YouTube live stream. You can chat with the person presenting and ask questions. It's typically like a 2 hours thing, so it's great for a Friday evening beer, sitting in front of the computer and doing fancy Kubernetes-based stuff. So we talked a lot about open source, but why does it matter to VMware, right? So why do we care about this, and what's the motivation? You probably don't think of VMware as a typical open source company. Who thinks VMware is a typical open source company? Okay, there we go. So why does it matter? So thinking back, and you probably remember VMware being like the virtualization company, right? So we introduced virtual machines and hardware abstraction so VMware just turned 20 years ago, 20 in this year or last year even, so 20 years old now. So we are out of our teen time. So what you're probably most familiar with is vSphere, right? So get it here. So vSphere is our core hypervisor and the core virtualization technology, right? But we moved on, right? So we introduced virtual storage with virtual SAN or vSAN here. NSX is a network virtualization layer. vRealize is our management suite to actually operate this kind of stuff in a very holistic way, and SDDC Manager, which actually takes all these components and does lifecycle management for them. Because we believe, so virtualization itself is a great thing, but you typically hit an automation end when you cannot automate the network, right? So typically the network becomes a blocking point, because as soon as you run a virtual machine, then you need to call up somebody in the network department to actually provision a new network and assign a new IP address and open up some firewall ports, yada, yada. It's like very lengthy process. So NSX is actually a new virtualization technology on top of the existing networking stack, where you can programmatically roll out new switches, new routers, new firewalls, new ports. So this is all happening in the same way that you could interact with vSphere to deliver virtual machines, right? And we don't really care how you use it, right? So you can use it for infrastructure as a service, for container as a service, for platform as a service, for desktop as a service, for function as a service, right? For us, it's all about, we coined that term here in Europe, it's a platform to run all the things, right? So we want to make it as easy as possible for our customers to offer to their customers, so to the DevOps teams, to the developers, to the business, a platform where you can have basically you have a runtime for everything, right? So you don't need to worry about it. And now comes the cool thing. So this is not just about your own data center alone. It's actually about running this so you can get this stack, this Cloud Foundation stack in the middle from VMware in your own data center. You can get it from VMware hosted on bare metal AWS instances, right? So you can run a VMware complete infrastructure stack on AWS, but actually managed by VMware for you. You can get it from Google. So Google is now one of the supported cloud providers where you get that stack from Azure, from IBM, Alibaba. So there's like a ton of the major public cloud providers. You can run that same stack in the edge and basically to all the needs that you have, right? But you don't need to, if you want to move, for example, a virtual machine from your on-premises environment to the cloud, you don't need to take it and wrap it in an EC2 format, for example. You can just take the VM, same format, and just vMotion it over to the public cloud. If you don't need it anymore, you just move it back, for example. So you get the portability, you get the interoperability on the same level here, right? And just from a consumption interface, mentioned it earlier, so it doesn't really matter what kind of workload you have. And we're totally committed to providing you that choice. And one of the big use cases here is edge computing, definitely, because just imagine you can run stuff in the public cloud, you can connect your virtual machines that you provision in the public cloud on this stack to an AWS native service, for example, build an application around this, but you don't need to change the legacy application to work on AWS, but you still get the benefits to connect it to the modern workload interfaces in AWS, for example. Or you build it on Kubernetes or whatever, right? So it's all about choice. So the idea literally is, so we want to, from our platform underneath, and we call this the software-defined data center, because from a software-defined data center perspective, you are supposed to be in a position where you can program into the data center and say, I want a new switch, I want a new router, I want a new compute pool. So we build on the open source APIs to ensure that you have maximum flexibility and no lock-in on the application layer, right? So you can move it around. But at the same time, we take care of all the integrations in the lower space, right? We started with OpenStack APIs some time ago. We have a Docker interface. So we can run against a Docker API. We do have Kubernetes interfaces. And in partnership with our sister company, Pivotal, you get Cloud Foundry. So who knows Cloud Foundry here? Nobody? Okay, Cloud Foundry is a platform as a service. The idea is basically coming from the Heroku idea where you take your code, drop it into, so you do a Cloud Foundry push, you hand over the code to the platform has build packs and builds the application for you, puts it into containers and runs it on the infrastructure for you. So you don't have to worry about the whole pipeline in between, right? So you take the code, drop it in, and the end result is a running application, right? That's Cloud Foundry. It's another open source project, and so in a year from now, just spoke with Victor earlier, so hopefully in a year from now we can have a joint talk here with a colleague from Pivotal. So Pivotal is currently being acquired by VMware, so we're bringing them into the family. So all of you understand the VMware Software-Defined Data Center is the best place to run modern apps, especially containers. But we are just getting started, right? So at our main conference recently, we announced a new portfolio name for this whole thing, which is called Tanzu. Tanzu stands for modern cabinets, but also for modern application, or modular cabinets, but also modular applications. It consists of basically three parts, right? It's a build, run, and manage story in this case. So if you look at the build phase, and this is exactly with Pivotal coming on board in the future, that's one of the big things, right? So who knows Spring Boot? Uses Spring Boot? Okay, so you probably heard of Pivotal before, so that's where this mainly comes from. So Pivotal has a huge platform to unlock this kind of developer productivity and how you actually build software, right? And they bring lots of cool things like a function service built on Knative, embedding then Istio, for example. The whole Cloud Foundry portfolio will run on top of Kubernetes going forward. So this is currently in beta and is going to come in the near future. Then we have, of course, Harbor as a container registry. So there are many of the components that will unlock, hopefully, the potential for you in the build phase, right? But at the same time, we acquired another company last year, which is called Bitnami. So who heard of Bitnami? So either you're shy or you haven't heard. So Bitnami is a company that takes popular open source projects, and they have basically automated all the things to deliver these applications in any format. You can get them as a virtual machine, you can get them as a container image, right? So they have like 180 different applications and components. They release like 1,000 times per month. And so their software or the packages are installed like 1 million times a month. So they are powering many of the public cloud stores and etc. So the idea is if you need a Redis database, for example, you can easily go to that marketplace and just get a Redis without focusing too much on building it your own or compiling it your own, maintaining it your own. Because whenever there is an update to Redis, we'll actually ship that as part of the marketplace. So if you haven't looked into what Bitnami is doing, take a look. There are many integrations with Kubernetes. They have something called Kube Apps, which is another open source project from them. Where they basically provide you like a front-end store to then run Helm charts or configure Helm charts and run it on your Kubernetes cluster, right? So in the managed piece, and that's another very exciting area. So with the rise of Kubernetes, we now see more and more Kubernetes clusters coming up. So Kubernetes is moving from being like a single cluster deployment to a large single cluster deployment to many smaller clusters. Actually, I'm seeing people using one cluster per application nowadays, one cluster per team or per effort, because it becomes so easy to operate these clusters and to roll out new clusters. So in the past, it was quite a hassle to set up new clusters, but it's a lot easier now. So we introduce a new component which is called Tanzu Mission Control. Tanzu Mission Control basically gives you a single point of control for multi-Kubernetes management, right? So you can attach existing clusters or you can roll out new clusters and you can specify policies on these clusters to actually work with them, right? So we'll introduce things like cluster lifecycle management, mainly built on the efforts that are going on in Cluster API in Kubernetes right now. Identity and access management. It will also come with audit and compliance capabilities, but also things like data protection, right? So if you think of the projects that I mentioned earlier, the Heptio projects, the blue logos there, that's a lot of the open source projects evolved into a service that you can easily use as a central point of view for controlling all the infrastructure. And then we have tons of other cloud services that we can interact with, like Wavefront, that's our cloud service for microservices monitoring, but also basically observability within the whole stack. So you can connect it to virtual machine infrastructure, you can run it in a container environment, which is very useful. It can take up to 1 million data points per second. So that's the scale at which this operates. Optimization, Cloud Health is for cost optimization in the cloud, and then things like NSX Service Mesh, which is built as a meta control plane on top of Istio, right? So because in the end, we say the same thing happening as with Kubernetes right now. There is a need to manage all the different Kubernetes clusters and all the different Istios that you probably have in the portfolio and apply like common governance and common policies to it. Yeah, and I mentioned attaching existing clusters, so from public cloud infrastructure, from AKS, GKE, but also your OpenShift clusters or what have you can be attached to transmission control to actually see what's going on. So this is how it looks like as of today, right? So you have the different clusters, you see the providers that are there. There is a concept of a workspace, which is a meta-level construct above a namespace, so you can have multiple namespaces belong to the same workspace, and you can apply policies to the workspace that will then be trickled down to all the namespaces that it manages, right? So this is literally a tool to manage a fleet of infrastructure, so potentially hundreds, if not thousands, of Kubernetes clusters going forward. So of course you can run it for 5 as well, but the idea really is to manage like all your Kubernetes estate through that. That's the workloads view, right? So you see what is actually running in there, and then the policies that can be inherited from the different applications, right? There is a ton more to come. So this is right now, it's built as a SaaS service, so you don't install it, it runs in the cloud for you and you just connect to it. So this is, yeah, so there will be new features added on the fly. So and the third component of this is the run piece, right? So, and run is something that is very at heart to what VMware does, and we are basically a run platform to make sure you have the infrastructure in place to actually work with what you need. So we have a product called PKS, or a set of products called PKS. PKS are our current enterprise Kubernetes distribution, and just a few weeks ago we actually first talked about what we're doing with a project called Pacific, and I'll give you a sneak peek of what's going on there in a minute. So let's briefly talk about PKS. So PKS comes in 2 flavors. There comes Enterprise PKS, which is an easy to install turnkey solution for setting up Kubernetes on your environment. But it actually works not just on your vSphere environment, you can also install it on a public cloud, right? So you can install it, it works on native AWS, on native Azure, on native Google, and on native vSphere. So you have a control plane to roll out Kubernetes clusters in a very easy way with Enterprise PKS. On the left-hand side, you have something that we call Essential PKS. Essential PKS is the Kubernetes binaries fully supported by VMware. So you can set them up as you like, in the form factor that you like, as long as you stay within certain guardrails, let's say, right? So you cannot do everything with it, but it's a super flexible approach if you have the expertise to run Kubernetes yourself, and it becomes a differentiator for you. But the idea is we can give you like last level support. So if you need somebody to help you out, you can phone up VMware and actually get support for open source Kubernetes. So how does Enterprise PKS work? And this is going to give you an idea of where we are heading in the future. So in Enterprise PKS, one of the key components is BOSH. BOSH is an automation engine that comes from the Cloud Foundry times, where this actually connects to your infrastructure as a service provider through an abstraction layer called Cloud Provider Interface. And BOSH understands how to roll out Kubernetes. So you get a Kubernetes package to put into BOSH, and BOSH then rolls it out to your infrastructure as a service. So this is all based on a public open source project, which is called CFCR, the Cloud Foundry Container Runtime. So we're building on top of that. So in the first place, when you install Enterprise PKS, you connect it to your infrastructure, in this case vSphere, The second thing you do is you connect it to your network virtualization infrastructure, which is NSX in that case, right? And from there on, you can easily provision Kubernetes clusters on the fly. And I'm not lying, so you basically take a command like this, pks create cluster, Kubernetes cluster 1, and I want to have 3 nodes. You hand it over to the PKS CLI, so that PKS CLI runs against the PKS API there. And the next thing you know is Bosch goes into vCenter, creates virtual machines based on images that are there for running Kubernetes, and it probably takes like 5-6 minutes, and then you have a fully functional Kubernetes cluster up and running with the number of nodes that you specify, with the number of masters that you specify. You can choose from 1 to 5. You have concepts like availability zones where you can say, okay, I want to have it here and have it there. And best of all, it comes with the whole network automation. So it not only sets up the Kubernetes VMs, it also sets up a dedicated network for the masters and workers, a virtual switch for every namespace that is created inside Kubernetes, right? So we are watching the Kubernetes API for changes and automatically create networking constructs that allow you to actually use that in an easy fashion. So what happens if, for example, one of these workers here dies, right? So it becomes unreachable for the system. So the Kubernetes master will discover, it's not working anymore. But Kubernetes is not doing anything about the worker, right? It's like, yeah, go fix it, somebody outside. And this is exactly what Bosch does. Bosch monitors all the component it rolls out constantly, right? And if the node itself discovers there is something wrong, there is an internal monitoring that is trying to fix it automatically. If they cannot fix it, they will actually go in and wait for Bosch to do something about it. So Bosch will actually come and say, you know what, VM is not responding anymore. We're not desired state anymore. Desired state was, I want to have 3 healthy nodes here, so we're only at 2 healthy nodes. So Bosch will actually go in, kill the VM, delete the VM, deploy a new VM, configure it back into Kubernetes, and have it back up and running in a few minutes. Right? So it does that all automatically. It discovers issues. You can also look into Bosch and see the health status if you want to, right? But it typically takes care of all of this automatically. You want to extend the cluster from 3 to 5 nodes, you just say pks resize cluster, boom, you got 5 nodes, right? Because Bosch always talks to the VM orchestrator, so it deploys a new VM for you and does all the automation around it, right? And again, NSX takes care of many of the network-related tasks. If you create a namespace, we create a dedicated virtual switch, a dedicated router. If you request a load balancer from Kubernetes, we deploy a load balancer. IP address is all automatically assigned. It's all pooled resources in NSX. And if you want to upgrade a cluster, for example, a new Kubernetes release comes out because of security patches or whatever, you get a new Kubernetes release from us that you just import into the workflow, into Bosch, basically. Bosch goes in, updates the masters, and then goes in and updates all the workers. You're done, right? And this can be done like any time of the day because it's a rolling upgrade that is, it's always coming from desired state to desired state. There is no unknown kind of thing because it's always declarative way of running Kubernetes. So this is what we have in the market for the last 2 years roughly. So that's where we are today. Very exciting project built in the open, and this is actually a joint product that VMware and Pivotal developed initially, also with Google on the Kubo front. So the other project that I mentioned is Essential PKS. So Essential PKS is basically this, you get upstream Kubernetes from us, always latest and greatest Kubernetes, but you can choose how to build it, right? So you can choose if your networking is NSX, or if it's Calico, or if it's Canal, what kind of registry you use. So we'll support you to a certain degree, even with third-party components, right? But the idea is you get maximum flexibility to roll out these things. So that's all today. What I wanted to do now is to give you a perspective of where we're heading in the future. So let me focus on this Project Pacific for a moment, and also briefly take a step back. So what is actually a workload, right? So how will a workload look in the near future, right? So you might need a Kubernetes cluster as one thing as part of the application. You might have some legacy components that run inside virtual machines that you need to connect to, right? you might have some existing database that you want to run as part of that, which is a traditional, like, I don't know, 3 VM database setup with some replication in between. And you'd have some pods or some even functions in the future because they make up the overall application, right? So when you look at the challenges now, so from a development perspective, so how do I deploy this app, right? Because it actually means you have a Kubernetes cluster to deploy. Damn it, that's already first step. Second thing is, how do you deploy the virtual machines, or different tool, different workflow, if there is an automation workflow that you can access either within your environment or the public cloud, wherever you are, right? And then databases, the pods. So it's like a ton of different areas to focus on. And from an IT operations perspective, it's like, so goodness, how do I ensure availability? How do I ensure it's secure? How do I deliver the quality of service and the resource allocations, etc.? And how do I control the cost of the infrastructure? Because if the developers can access it, it will all go mad, right? People will just deploy clusters like crazy, and the infrastructure will never come to a rest, right? So what we do with Project Pacific, and it's technology preview right now, but this is where we're targeting the next, or the evolution of vSphere to be in. So what we want to do is make all these pieces deployable through Kubernetes. So deploying a new Kubernetes cluster could be a YAML file like this, right? Deploying a virtual machine could be a YAML file like that. Deploying a pod would be as it is today, right? And then even deploying, I don't know, SAP HANA databases or whatever through a YAML interface like this. And you remember what I said earlier, Kubernetes is a platform, right? Kubernetes is highly extensible, so you can explain to Kubernetes how a resource looked like in form of a custom resource definition, and then you can interact with that resource and actually use stuff, right? So if you look at the top left, for example, the Kubernetes clusters, that's something that's currently being specified in the Kubernetes community through Cluster API. So in Cluster API, what happens is that this whole setup of a new Kubernetes cluster is so abstracted that you can basically let Kubernetes run Kubernetes. So instead of saying, I want to have 5 pods Kubernetes, you can say, I want to have a cluster with 5 workers Kubernetes. And Kubernetes will take care of that, right? So the whole, the control loops that Kubernetes has will go into the infrastructure and continue to work on the infrastructure until the desired state is met, right? So it will work until, for example, a 5-node cluster has been deployed, right? So how does it feel like when this all comes together? So we see the namespace as a massively helpful unit of management, right? So the Kubernetes namespace construct is now being transferred into the core vSphere hypervisor. So we'll use the namespace to basically have a logical boundary around a workload, right? And that namespace can include pods, it can include virtual machines, it can include Kubernetes clusters, and then you can do all kinds of fancy things with it, right? So you can say the quality of service, so the priority for this workload is very high, right? I want to have reserved capacity for it. I want to encrypt all the persistent data that's part of that namespace because it's a PCI relevant application, for example. You can disallow certain ports because it's all running in that virtual networking environment as well. And from an availability perspective, you can say, okay, I want all the disks to be replicated across multiple sites. I want to have snapshots to back up. So this is exactly where we're trying to go, right? And access control, of course, you say who has actually access to that kind of namespace, right? But instead of building tons of tools around the infrastructure and around Kubernetes, we're actually embedding Kubernetes into the core of our hypervisor to make that a new abstraction layer that you can easily consume, right? So what was necessary, so this is how virtualization in VMware looks right now. So you have the VI admin, the vSphere infrastructure admin that talks to vCenter and manages the virtual infrastructure consisting of individual physical hosts with our hypervisor installed. And in that hypervisor, we have a process called hostd, which is basically the management interface for vCenter running virtual machines. So what we did is we added a new component called the spherelet, and the spherelet is our adoption of a kubelet, which natively runs on the hypervisor. And we added Kubernetes master VM on the side to allow the interaction with Kubernetes, right? So what you're looking at here is actually becoming a Kubernetes cluster, and not only you can run virtual machines on that, but you can also run pods natively on the hypervisor, right? There is no need to spin up a virtual machine to run pods in there anymore, but you can run pods directly on the hypervisor, right? So that's a key difference, and this will make a lot of impact. We outpace bare metal performance in that model already. If you, I mean, who wants to run Kubernetes on bare metal anyways, but it's even better than that. So we call that a supervisor cluster. And that supervisor cluster is our entry level. So from there, the developers can request, for example, a new Kubernetes service, because we can easily deploy new Kubernetes clusters through Cluster API because it's just there, right? So that's the first thing. Second thing is you can order virtual machines through it, right? So you can say kubectl virtual machine pops up in vCenter. So you see it as a virtual machine, but it's actually managed through the Kubernetes APIs. And it could be anything as a service going forward because of the extensibility that Kubernetes delivers, right? So you can actually teach Kubernetes to learn how to roll out a database or how a database looks like, and then apply that and actually have those databases there as well. At the same time, IT operations will continue to look into vCenter and also potentially in Kubernetes if they like, but you basically have a common ground where the workloads will run in the future, right? So that's the high-level overview of what's happening there. So very excited. So if you run some VMware in your infrastructure, that's where we're going, right? So I hope that was a little useful. So that's the summary again from a Tanzu perspective, and I'm 3 minutes before the end, so thank you for listening. Any questions? We have a translator in the room as well. Have a wonderful conference.